So I think it's the same weather, same as Montreal. I mean, same as Oakville. It was same, no difference. But yeah. All right. All right. So yesterday we talked about this one. Okay. All right. So did you guys work on this one? Did anybody try? Okay.
Longest line.
So if I have to ask you, like, find the top 3 longest line, what would you do? If I ask you the same question, the only difference is find the longest line from the file. How would you solve? This thing that we discussed yesterday was all clear to everyone, right?
Yep.
Yeah.
No doubt on this. So if we have to extend this question to say that find the top 3 longest lines from a file. What would you?
One way would be that here we are finding the longest line. We can maintain, rather than just maintaining one line, we can maintain 3 lines and then check out of that, right? Maintain in the sequence 1 to 3, and then see which is the smallest one. And then every time check with the smallest one. If it is greater than the smallest one, then replace it. Then check the second one and so on. And whichever it is, just replace and move the stack accordingly. So maintain 1, 2, 3 counter, or maintain 1, 2, 3 variable. Always check the third one, which is the smallest. If it is smaller than that, it is smaller than that, then go and check the second one. And if it is second one is it is again bigger than the second one, then go the first. Wherever it lands, shift the other one down. And do that for every line.
Okay. Help me then. Okay. So we open the file, right? What should I maintain? Top 3 lines so far. Okay. So I'm saying go for iterate over this file handle, and then now you help me. So top 3 lines. Okay. Okay. So you are saying that we will keep them in order, right? 0th will be shortest, and
Yeah, I
first
mean, you can either keep them in order or always know which is the smallest one. If it is less than smallest one, then just pop the smallest one out.
Okay. Okay. Yeah, help me then. So we are saying we are maintaining 3 lines. Okay. In this, it will be ordered, right? Based on shortest to the longest, correct?
Yep.
All right. All right. Now, okay. All right. So basically, what you're saying that we will pick, okay. All right. Help me. Okay. So yes. Help me code.
Yeah, so rather than having top three lines, right? Yes, so now check if uh, yeah, when you say max length, right, rather than max length, just check in line number 7.
Okay. All right. Yeah.
Yeah, if the length of the new line is
Okay.
greater than um, top line 0, we are assuming it is in um, ascending order, right? So 0 is
Okay.
the smallest one.
Okay.
Okay. So top line 0 is greater than, then check if line.
No, what we can do is we can just replace top 3 lines and we can just say append and we'll maintain something called what do you say length also. Okay, we are going to maintain length and line. What do you say?
Okay. A list of top. Okay.
Okay, so we are saying here, okay, this. I mean, instead of this, we'll just say, okay, yeah.
It should be line, right? 3 lines, 0 equal to length of line and lines. Lines, it's a typo.
Oh, yeah. Thank you. This one, right? So we're maintaining a tuple. The first one value is the length, and second is the actual line. Okay. So that's what you're going to maintain. So you're saying that if length of line, the new line, the one that we encountered, if it is greater than the 0th line, then you basically replace the 0th line with this. Is this okay? And then,
Sorry, line number 6, right? You have to just check top line 0, right? 0.
So it might be initially first initialize the first line come to the any loop like file reading. We assume that this is the shortest line. Then we compare. Otherwise, top line 0 is empty. Then might be give me the error. It will not
exactly.
exist in the top line in the initial case.
So, okay, so you are saying if length of top lines, top 3 lines, okay, very good point. If it is, let's say, less than 3, okay, just simply put it into, okay, append length of line and line. And then we basically are saying top 3 line dot sort. Okay. So we are using the inbuilt method of sorting the lines. We will see if we can optimize it.
But then the sort will happen on the length variable. I mean, how does it happen in Python?
Yeah, very good question. So when you have an array, right? When you have an array, let's say this is my list. Okay, 1, 2, 3. 3 minus 1, 2, 4. Okay. And if I say a dot sort and then print a, okay, so it'll automatically sort it based on the value. Correct. Now, if you have any, anything, let's say you want to sort it based on something, okay? Let's say this was your list, and now you want to do a reverse sorting, okay? So you can always define a function, right, as we discussed, that anonymous function you can define like this. Okay, so I'm defining a function. What it does is it provides a logic to it. Okay, so it's providing this what? lambda. Okay. 1 second. Doesn't it? Okay. We'll just define a function. Define f.
Hi, Sandeep. Hi, Sandeep. Yes,
Yeah, I got it. You were saying?
yeah. Actually, instead of maintaining a tuple, can we just maintain a list? And in the second case, in the second if, we can just check whether the length of the line is greater than the minimum of the top 3 lines, min of top 3 lines. So is
Yes.
it possible to do that?
Can you repeat? Can you repeat?
So in the second if statement, so we
Second
can
statement.
we can just check that if length of line greater than minimum of top 3 lines.
Yeah. So basically we are anyway, since this list is sorted, we are basically just checking with the smallest.
Okay, so in my case, is sorting needed really?
So what will happen is, if let's say for every line, it will go and check thrice. Correct? For every line when it encounters, if you do minimum, right? Every time you call the minimum, what will happen? It will go and check thrice. Correct?
Okay. Yeah.
So that'll be three hops. Correct? That's
Okay,
why to avoid those 3 hops per line, I am just keeping it sorted.
and what is the sorting and what is the time complexity of sorting and finding the minimum?
Yeah. See, sorting is happening only on 3 elements, and that too is happening when the thing is modified. Okay. So if like every time you find a line and we are sorting, that one is going to be constant time. Even if let's say we go with your way, right? We don't keep it sorted and we every time we check. You will have to remove the shortest line. So you have to first find that line, remove the shorted line, and then you have to do it every time. Correct?
Yeah.
So that's why.
Okay. Good.
So in your case, what will happen is the time complexity of this will become thrice of On. And since 3 is constant, we'll still be calling it On, right?
Yeah.
And
So that's why I was asking.
yeah. So but if I tell you that find me top K lines from this file.
Yeah, that it will be applicable on this program only. In other cases, the sorting will be better, I think.
Yeah.
But if there are more lines, then sorting will also be.
Yeah, but sorting is happening only if you notice a new word. I'll come back to like improving the sorting method, okay? Because sorting is very painful in this. Okay?
Okay.
Sorting is very painful in this because sorting is going to be n log n. And
Yeah.
in this case, is 3 log 3.
Okay. So
Okay. Are you guys okay with this?
So, yeah, we
No,
need
no.
to pop. Oh, we don't need to pop. Okay.
No, so
No.
Sandeep, yeah, no, about the sort thing. So in a 2-dimensional this thing array or tuple, so when we say sort, it does it on the first index, is it?
Yeah. So if you say, let's say you do sort, okay?
Right.
So it'll basically just compare the values, right? Like
Right.
this. But if you put things like this, okay? I'll give you better examples. Okay, I will insert one more. Let's say here, okay, 1, 1, 1, 2. Okay, and let's take a look. 2, 2, and let's say I'll shuffle them just to be very clear. 2, 10. Okay. Okay, just to be very, very clear. So if you see, first it compares the first elements. If those two are same, then it compares the second element. Okay.
Oh, okay.
And then similarly here. So it orders the data based on, this is like a lexical ordering. Okay. First value, then second, and so on. Okay, so basically, the other way to quickly check this is this. 1, 1, 1, is it less than 1, 1, -1? True or false. So it basically compared all the values were same, and therefore, basically, if you see, it noticed that this is smaller than this one. Okay. So 1, 1, 1 is smaller than 1, 1, 2. Okay.
Okay.
And similarly, you can also check more things. You can also see 2, 1, 1. Is it less than 3, 1, 1? Yes. Okay. And you can also see this one. Okay. All right. So 2, 10, 10 is less than 3, 1, 1. You see that?
Yes, got it.
Okay. So this is lexical or ordering, or you can. Okay. Just like in dictionary, we compare the first letter. If those are
Yeah.
letters are same, then we compare the second letter and so on. Okay. Perfect. All right. All right. Now, is everybody able to understand this code, what we are trying to do? Basically, we have a file and we are trying to find top 3 lines from the file. Okay. So what we did was we opened the file. Okay. We got the handle. Then we are creating an empty array of 3 lines. So we'll go from top to bottom in this file and basically maintain 3 lines. Okay. Initially, we'll just pick the first, any 3 lines we get, first 3 lines, and then we'll start checking which one is smaller, which one is like that. Okay. So first attempt could have been the way somebody was explaining, that we would basically check with what's the smallest line, and we replace the smallest line with the new line. Okay. Basically, just go and find whichever is the smallest line and we replace it. But that could have been a little more slower. So what we did was, we are keeping these 3 lines in a sorted manner, sorted based on the length of the line. So in the top 3 lines, we are maintaining a list of 3 lines. Each of the line is represented as a tuple. Tuple is nothing but a pair of values together. It's a basic data type in Python, where if you have multiple values, you put them in tuple. Tuple is little more faster than arrays, okay? Though arrays and tuple can be used interchangeably. If you don't have to modify the values very frequently, then it is better to keep those values as a tuple. Okay, so tuple is like a pair of values together. Okay, single values are basically normal values like x equal to 10. But if you are saying x equal to 10 comma 1, that's a tuple. Okay, so we are keeping the tuples, the length of the line and the actual line. That is the tuple. Okay, and every time we are inserting a value into it, we are sorting it. Is this okay, or would you recommend a better
Sandeep,
method?
I have a question. So, here in this, if we are getting a line with the same length, like I have three lines with same length, then it will replace it based on the lexical order of that line, right?
Yeah.
So that will be okay.
Basically, no. Yeah. Basically, it will only if the length of okay. You can see it'll just check the length. If the length of the line is bigger than that, then it will replace.
No, I have already have the length as 60. Let's say it's 60. So my length is 60 and I have one line. Now
Yeah.
again, one more line came, which is 60 and
So it
maybe
won't do
it's
anything.
greater.
It won't get into this loop. Huh?
It is basically, if it is greater than 60, oh, okay. Oh, okay. It's greater than 60.
So
Okay.
if there are like 100 lines with all same length, then it will only pick up the first three and ignore the rest.
Yes. Okay. So it has done the job. Okay. It has done the job. And yeah. Okay. So okay. So what you see here is you know, it's kind of a very how should I say? It's a little inefficient code. Okay. It is a little inefficient code. Right? If you see because we are sorting already sorted data, correct? Say we have 1, 1, 2, and 3. These are the 3 lines, okay? Top 3 lines. We get, let's say we got another line whose length is 2. What we are doing is we are replacing this one with 2.
Sandeep, you are sharing something.
No, you can't see my screen?
Screen I share, you
No,
write
we
something.
can. No, you
We
wrote.
can.
We can. No, now we can't. You wrote something.
I cleared it. I cleared it.
Oh, you cleared it. Okay.
Yeah. So, yeah. So imagine, let's say initially this top line is empty. It encounters the first line. Let's say first line says 1, 2, and 3, and 4. Okay, these are the four things that is there in the file. So let's go one by one. So it encounters 1. The length of top lines is less than 3 right now, which is empty. So it puts in that list, what does it put? It puts the length of 1 is 3 and it puts 1. Okay. Then again it puts 3 and says 2. And then it puts 4 and 3. And after this, it has sorted this list. Okay. So every time it's adding something, it is sorting it. So 3, 1, 3, 2, 4, 3. That's okay, right? Now it comes to this. No, this is not 4. This is 5. This is 5. Okay. 3, 1, 3, 2, 5, 3. There are 5 letters. Now it comes to FORTH, right? So what it does is it replaces this. When it comes to 4th, it comes here and checks. check, okay, this has got 4 length and which is bigger than this. So what it does is it replaces this one. It replaces this one with 4. No, not 4, 5, and the name is 4th. Okay. And then what it does is it sorts the data. Okay. Now, while sorting, it does all the heavy lifting. Sorting basically is a complex exercise. Usually, if you have n number of records, the complexity of sorting is n log n. I'll talk about this very soon. Okay. So, okay. So what it does is it basically that sorts the entire thing. Ideally, we should not need to sort it. We should have done it this way. That, okay, since this data is anyway sorted, we could have just, went here and swapped the values or inserted this value somewhere in the midway. Okay, but I'll talk about that very soon. There is a strategy called Min Heap. Okay, using that strategy, instead of sorting it every time, we will use a data structure called Min Heap, which automatically keeps the data sorted and keeps the minimum value at the top. So we'll just pluck the minimum value, it will automatically sort it, and then and that sorting is very efficient. So we'll talk about Min Heap and sorting very soon. Till that point of time, this code seems to be okay. All right. Though we can do way better. Okay, if we have to find k longest lines from a file, then we would use that strategy. Okay, we'll talk about that soon. Perfect. So this is our way of reading the text file, and we also understood that many a times reading the text file into the memory is not always a solution, so you have to apply the strategies. Okay, also reading file is slow. Therefore, reading the file multiple times does not make sense. That is another thing that we studied. So reading file is slow, and therefore we have to be very, very careful. Okay, now let's say here is a question to all, that we have this mbox-short file. From this file, we want to find out all the lines that start with subject. Okay, that start with subject. So who can help me? So question is, write a function that takes a file name and prints all the lines starting with a prefix. The prefix is also, let's say, a prefix is also a argument, right? So, right, starting with, okay, or you can say get starting with lines, okay. This is the file name, and then this is the prefix. So we want to find out all those lines which are starting with prefix. Who can help me quickly? Yeah, please step up.
For loop.
For
First we'll open the file and
open the file. Okay, we'll just make one change to it. Okay, instead of opening and closing it, we'll just use this method. Okay, so it will open, and as soon as it gets over, it will close the file. Yeah, now
for line in file name of which if line starts, there is a method called starts with three for strings, line dot starts with
okay,
subject. What is that?
this should be good enough. Okay, All right, would it work? All right. It says that, okay, let's just say, it says the string object does not have a method called starts with. Okay, let's
Start,
just,
right? It start.
I think it's a typo, right?
starts with.
Starts.
No,
S is
yeah,
missing.
S is missing.
Okay, so it has found all the lines that start with subject. Okay. All right. Good. It found all the lines starting with subject. Perfect. Very good. Very good. So far, I think this code should be clear to all, right? All right. Yeah, this is one another issue that each line, when you are reading from the file, it has an extra new line character. And that's what is annoying. Okay. This is very annoying. So one new line is being put by the print function. The print function is also putting a new line, and the line is also coming with this. So how do you deal with it? You can say print line, and we can say strip. Okay. So the strip command removes the new line from anything, beginning or end. So it has done the job. Okay. All right. All right. Let me move ahead. Okay. You can use R strip, remove the new line from the right hand side instead of only also instead of both sides. Okay, strip removes the new line or any of the trailing blank spaces by deleting them. Okay. Now, if you want to skip some files, you can use continue. Okay, what continue does is instead of going down, it goes back. Instead of going forward, it basically just skips everything and starts from the beginning. Okay, beginning of the loop, it skips the entire content of the loop and goes to the beginning again. So that's what it does. Okay. All right. So this was a way to read the data. Let's take a look at a couple of examples where we are writing to the files, and then we will move on. Okay. So let's say we want to write the data to the files. Okay. Now let's say we want to grab this, we want to change this function. Okay. And we want to change the name of the function called to save results. Okay, here is okay. Now let me be very clear to you. The question is, find all lines containing a keyword, okay, and save them to another file. Okay. Find all lines from a file containing a particular keyword and save them in another file. Okay. So what do we want to do? Save, and we'll call it save graph. Okay. This is the input file. This is the keyword, and this is the output file. Okay. Now, who can help me with this logic? So what we want to do is we want to write the data to the output file. Okay. So whatever we are finding. So first we'll open the input file. Okay. FHE, okay, we'll call it in INF, okay, or should we call it INP, input file, and we'll call it open input underscore file, okay, and then we are saying output file equals open output underscore file, and we are providing the write method, okay, and then what we are doing is, if the file does not exist, we want to create it. Therefore, we are putting W plus, okay. W plus means we are reading. This one is read method. So by default, it's read. So we don't have to explicitly say. But when we want to write the data to the file, we want to open it in a write mode, okay. And then we say for line in input file, okay, if INP contains the keyword, we are going to write it to output file, write line, and then we close output file, and we also close the input file. Okay, is it clear, everyone? Is there a doubt on this? So we open the input file, we
Sandeep,
open
what is that W plus in output?
yes, we want to, the file can be opened in two modes, read mode, write mode, right? So if you want to open the file in a write mode, you will use W. If you want to say that if the file is not existing and create it, then you can say W plus. Okay. As far as I remember. Okay. Open file Python. Okay.
I think there is an append mode also, some X.
Yes.
thing.
Yes. There is an append mode. I think it's called A. Reading and writing. File methods of read, write. Okay.
Will it create a new file if the file doesn't exist?
Yes.
W creates a new file, right?
W writes
plus?
to a file. W writes to a file. Okay. And as far as I remember, the first argument.
also could.
Okay. The second argument is another string with few. Mode R when the file will be read. W for writing. An existing file with the same name will be erased. Okay. A means open the file for appending. Okay. Any data written to the file will automatically add it to the end. R plus means open the file for both reading and writing. The mode argument is optional. Or if you do not provide it, it will be read only. Okay. So there is a W plus, I very well remember. They have not mentioned W plus. Why have they not mentioned W plus? Have they removed it in new versions? Let's just test it
W
out.
plus.
Okay.
W plus is for read and write both, right?
R plus is read and write both.
So
Okay.
can we use that R plus instead of W plus?
I'm not sure if how does it work, the reading or writing. So, but we can give it a shot. Okay. I'm not sure how would it work, because if you say read and you're reading the same file and you're writing to it, how would that work? Okay. So it's better to be very clear that we are reading the file or writing the file. This is, I don't know why have they introduced it. Okay. All right. Let me test it out. As far as I remember, okay. W is okay. Okay, so there is X. Okay, there is X. Okay, X means create a new file and open it for writing. Okay, we'll just leave it like this. Okay. All right, so we have, let's say we have a file named mbox-short.txt. Our keyword is, let's say, from, and our we are saying mbox results.txt. Okay, let's see. It says that the object has no attribute called contains. Let's see what is happening here. We are saying for, no. Okay. Here we are saying line. Line. All right. So it says the string object does not contain that word. Okay. So let's take a look. Does it have contains? I don't think so. Okay. All right. Let's see if index is good enough. Okay. So it says ABC is found at that location, C is found at 2. So I think index is good enough. If line index this greater than -1, okay, it says that the substring not found. That's not a good idea. I don't want it to throw that error. Instead, there is another method in strings. What it does is it checks ABC in ABCDEF. Okay, so this basically checks if ABC exists in another thing. So we can also use that method where we can say keyword in line. Okay, keyword in line, and that's about it. So let's see if it has created the mbox results. Okay. I'll execute the Linux command by putting exclamation in the beginning. So yes, it has done the job. Okay. So is this code clear to everyone?
A couple of questions, Sandeep. So one was that if keyword in line, that's clear now that you have explained. But if we see the line number 6, which is out file dot write, I mean,
Yes.
I was reading the first time when you wrote line number 5, which was, I think, file contains, right? That felt very like a natural language flow. I could like read it and remember it in some sense, but then it gave a bunch of errors.
So no, but the text, the thing doesn't have, the string doesn't have a contains the method. Okay. Because I kind of sometimes still recall Java. In Java, there was a method called contains. I think that's where it comes from. Okay. Still bad habit of Java. Yeah.
And then in line number 5, when we are saying if keyword in line, okay, so, because we are clarifying it in line 4, that for line in the input file.
Yeah. So you can think of it this way: A in A, B, and C. Okay. So it says false. Okay. Now this is true. A in A, B, C is true. Similarly, you can also say A in A, B, C. Okay, so that's also true. You can quickly test.
Yeah.
That's what I'm saying. So keyword in the line, if that is true situation, then it puts it in the output.
Hey, Sandeep, quick question. So mbox results.txt, was that
Yes.
file already there, or can you just put a random name and see if it creates a file, or
Yeah. I think it creates a file. It creates a file. Let's say 1, 2, 3, 4, right? So let's take a look. So it creates a file by default. That the W creates the file. You don't need to say W plus. Okay. And if you
And it
do
does.
this again, it will delete and create again. Got it? Yeah. You were saying?
Yeah, and I'm saying it does understand, like I'm asking for from only when F is capital.
Yes, because if you see here, if you say capital A in ABC, this is false.
Mhm.
Got it?
And if I want to do like show capital F and also small f, like a bunch of forms of from, I can do
Yes.
it as part of within that code in the second one.
Yeah. What ideally you should do is, in let's say you want to ignore case. Okay?
Yeah.
You want to ignore case. Right now, I'm not ignoring case. All right. So what you do is, first, whatever keyword the person has given, change it to lowercase. Okay. The way I would do, I would say, whatever keyword you have given, I am going to convert into lowercase. Okay. Similarly here, I am saying line equal to line dot lower. Okay. Now, rest of the code will remain as is. Okay. Now, you see, it has basically found these lines also. Oh, it has actually changed the original one also. If you don't want that to happen, you can say line 1 here, and that is all. Okay. Now that this is all okay, right? So you can ignore the case using basically folding both of them into lowercase. All right. Is everybody okay with the read write of the file?
Yeah.
Hi,
Some,
Sandeep.
Yeah.
You can
yeah, just a small question. Instead of deleting and recreating the output file, can we also append in case if we need it?
Yes.
It
Okay.
is okay.
You can basically, if you keep right here, if you're saying A, it's going to keep appending.
To
All right.
whatever existing file content.
Yes.
Okay.
Yes.
Thank
You can check the length of the file. It should increase. Right now it has 54. I'm executing again. Let's see. It has become 81. Now it has become this.
Oh, thank you.
All right.
Hi, Sandeep. So if
Yeah.
you want to check multiple keywords, then how can you do it?
Yeah. Okay. So let's say you want to do a multiple keyword search, right?
Yeah.
In what way? You want to do like either of the keyword is found or all of the keywords are found.
Either.
Okay. So let's say the question is, from a list of keywords, find from a list of keywords if either keyword is found in the line, okay, save that line to another file. Okay, now who will help me? I'll say multi. Okay, save grep multi. This is my input and I'll call it array. So I'm passing an array of keywords, and when either of the keyword is found in this file, then we put it in this. So who can help me here? We'll go in a file line by line, and then we will search for all the keywords. Okay, so we could say if for, right, for keywords, keyword in keywords, Okay. And we will say found equal to false, and we will here. So we are checking all the keywords, right? If a particular keyword is found in the file, we will say found equal to true and then break. Okay. And or not needed, just don't check other keywords. No need to check other keywords. That's it. Should it work?
Yep.
So let's say this is my mbox dash short. Okay. And I'm removing the lower, like changing the keyword to lowercase right now. Okay. And let's say one keyword is from, other keyword is subject, and other keyword is at the rate. Okay. And if any of them is found, I'm going to put it in another file. Okay. Output mbox multi.txt. Okay. Let's see. It says local variable keyword is referenced before being used. Okay. Why it is that? Oh, because earlier line 1 is not defined. Okay. Now I've corrected all of that. Now you can see. All right. So it found from, it found at the rate, and it is basically found at the rate here, and so on. Okay. If let's say here, if I change this, I'm using append. Instead of append, I'm changing it to write. Okay. Now it has basically listed all those lines you can see where from or subject is found. So it is working fine. Is it clear? So what I did?
Yes. Yes, Sandeep.
All right.
So if like we need all the keywords, then it will be much more complex.
Makes sense, right?
Yeah.
Perfect. Okay. Why am I doing break here? This break will break the for loop because let's say one line contains multiple keywords. We will end up writing this line multiple times into a file. We don't want to do that, correct? We only want to do it once.
Good.
If multiple keywords are found in a line, then it should not print that line multiple times. That's why the moment one keyword is found, we are breaking it so that it doesn't look for another keyword. All right. Is everybody okay with this?
Python has an internal function contains, although it is not exposed.
Oh, okay. Okay.
You
All
can use
right.
underscore if you want.
I see. All right. I think that in internally is calling that contains.
Right.
Okay. Let me commit this code so that everybody has access to this notebook. Okay. So I'm going to Python. All right. Git status. I have not added this line. This is not needed, right? You can create this. All right. The output files I'm not adding to the repository. Okay. So that you all can access it. Okay. All right. Why does it keep giving? I just delete the line number 8. Okay. Line number 8. Again. Line number 4. How many times? Okay. It worked fine this time. Okay. Perfect. All right. So that was brief. That was a very brief about the files. Lists, everybody has gone through lists, so I don't need to really, explain list much. I think everybody is clear about the list. Dictionaries is something that I want to start with. Okay. Or is everybody clear about the dictionaries?
I am not. I would appreciate you going over it, please.
Okay. All right. So far, what kind of variable types we studied? What are the various variables that right? Like variable types, what all can we have? Okay. Int, and then a string, float,
Complex.
what?
Float, integer string.
Booleans. Boolean, those who are not aware about booleans, the true or false, right, are basically two values that a Boolean variable can take. Okay. So Boolean, what else?
Tuple.
Tuple. Tuple is like this, okay? Tuple is like 1, 2, okay? And tuple can be a combination of things. You could have, let's say, 1, Sandeep, another tuple. Okay.
But is that not a list type? Like type?
No. The type of, you can check the type of
list. Okay.
The tuple or tuple is basically something that you cannot modify later. If I want to change a particular value, it'll throw an error. Tuple object does not support item assignment.
Yeah.
Okay. Now, what else? 6.
List.
List is something very clear to all. You can just say, okay, this is my list, and list can have another list, and that list can have a tuple as well, and that can have further another list. Okay, so there is no limit to it. As long as the memory is allowing, you can keep on doing this forever. Okay, so list. What else? What?
We did range.
Range.
Range is not.
Range is a part of list.
Ah,
okay, so if you see what's a range, range is something like a iterable over which we can go. Okay, so range is a function that generates a range of values which you can try, which is like something like a list. Okay, internally. All right. List parent class is actually range. Okay. All right. What else? All right. Anybody? Function basically. Yes, you can actually define a function, right? You can define function like this. Okay, so if you call x on any string, it'll basically convert it to lowercase. So what we did was we created an anonymous function, assigned it to x. So X, the type of X is a function.
So then none will also be a data type, right?
None is a
Sandeep?
data type. Yes. Is a value. Yeah. Is a value. When it is a value. So you can say 8. You can actually put none also. Okay. Because when you say X equal to none and you say type of X, it says none type. Got it?
Sandeep, I didn't get this function thing. Like, what's the utility or the usefulness?
So
Why
when we
will
are
we use
defining
this?
a function, okay, let's say we are defining a square function. So the f is like a variable, okay? Like f is a variable whose type is a function, okay? You can assign this f to g and you can call g just like f. So
okay.
So function is, and you can pass the function into, as an argument. Okay. Therefore, function is also a data type, right? You could say, okay, this is my list of functions.
No, but
Okay.
no. What I'm trying to ask is, what will you get if you write g equal to f? You have defined a function, anything,
Yeah.
right? Like, and
I
then you say
wanted to
g equal.
just show you that function is just another data type in Python. You can
Okay.
treat it like another variable. You cannot do that in Java. You
Right.
cannot do that in any other language.
Language.
So
Okay.
you can pass a function in another function. You can maintain a list of functions in a list, as a part of list. And then you can say for my func in list of functions, okay? And you can just call this my func on 10. Okay, and then print it. So you can see we are able to call the function as arguments. Got it?
Yes.
So function is nothing but a data type. Got it?
Yes, thanks.
Hey Sandeep, what is the difference between the lambda thing and the function, like variable equal to function?
There's no difference. There's no difference. So either you could define a, let's say, square or cube. Let's say you are defining a cube function. You can take an argument like this, cube x, and then what you could do is you can just say return x into x into x. Okay, that is a cube function. Okay, and the other way could be that you say, okay, my function, my cube equal to lambda x and say x into x into x. Okay, so my cube is again same function like this. So here we are defining a function that doesn't have a name. We are saying define a function that doesn't have a name. And this is a quick way of defining functions because you can pass functions as arguments. So when you want to create a function on the fly for which you don't want to give a name and you're too lazy to type the name of a function, then lambda is very useful. Okay. But again, it is not that useful, honestly, because lambda functions should have single statement in the body. That is a limitation. And second, you have to again type LAMPDA instead of just define a function using DEF. Okay. So I think, in my opinion, lambda basically is not that useful. Okay. Lambda functions are nothing but anonymous functions that you just basically use them and throw them. You don't give it a name. Okay. You can actually just check there is no difference between my cube, which is a function, and the type of cube, which is also a function. Got it?
Yes.
All right. So these are the things that we have studied so far. Okay. All right. Let's move on. Now, Python has something called dictionaries. Dictionaries are cool. You can, in case of list, you only have, you define a list, you access an element based on the index. Okay, based on the index. So we access the 0th element. But what if instead of an index, you want to give it a name, right? Just like when you are referring to Excel sheets columns, rather than accessing them by index, you want to give them a name. This is where the dictionary come into play. In case of a dictionary, okay, you give a name. This is my name, and I'm saying the name is Sandeep, and let's say age is 43, and let's say height is 5.5. Okay, I'm just putting it like that, right? So what you see is that this is a dictionary, okay? Notice that the key has to be either a string or a number, okay? We could also say things like 5:5, okay? So the dictionary, the name has, the key has to be primitive data type, either decimal or a string, okay? Or the name could also be a tuple, okay? You could also have name as a tuple, okay? Let's say 5:5 colon true, okay? So you could, basically the key could be a tuple. So the key could be a basic data type or a tuple, okay? I hope this makes sense to you.
Yeah. So this is like a hash map in Java, right? Something like that.
Yes, exactly.
Key variables.
All right. So let's take a look at the D. D is a dictionary. Okay. You could also define a dictionary, empty dictionary, just like this, or using this way. Okay. There's no difference between the two, D1 and D. There's no difference. Okay. So you can define the dictionary and you can add the value to a dictionary in a very simple way. You just like an array, instead of using numbers, you use the name. Okay. Okay. So I've added a key called name, and then we can also add, let's say, D, and I'm saying age, and I'm putting age as, let's say, 40, and I'm saying D, and here I'm putting the coordinates of something as a key and saying that is found. So you can see I'm able to, go over these values, right? Now, if I say d.keys, it gives me all the keys. You can see name, age, and the tuple.
Yeah.
That's my key.
And what about values? D.values, right?
Yeah. So now the question is d.values, does it return? Yes, it did return. But this is not very useful because you don't get the keys. A better idea is using items.
Items, yeah.
All right. Now you can iterate over the keys. You could say for key in d.keys and say print key. So these
Sandeep, yeah, the best use case for dictionary is like uploading the data in some, symmetrical database actually, or a database table actually.
No,
Right?
there
Like,
are lots of use case. You will find that dictionary has got the highest number of use case. Okay.
Oh, okay.
Let's just take some problem. Let's just take some problem like 5. Hello?
Yep, yeah. Sandeep, you break out for a second.
Yeah, there was an echo. I don't know.
Yes, Sandeep, I think somebody has their speakers on that's causing the echo.
Yeah,
Is
I'm
it?
getting an echo for most of your lecture today.
Is it?
Yes.
He
No,
wasn't
I
facing
did
it.
not.
No, I am not getting an echo.
I'm not getting.
Suppose I think it's your thing.
No, I think, yeah, maybe somebody had kept you on speaker, so I was getting an echo for that. But now I'm not getting, so let's see.
Okay. Now, let's say what I want to do is, okay, what I want to do is from the like first question, okay, first question to all of you is, okay, find the frequency of words in the file, in a file. Okay, meaning how many words are there in the file? In a file, find the unique words and find the frequency of that each word. Okay, imagine the file has, this is the cow. Okay. I hope you've got the idea.
Yes.
The cat jumped over the rat. Okay. So the is 2 times, cat is 1 time, rat is 1 time, and over is 1 time, and what else?
Jumped.
Jumped is 1 time, correct? So basically this is what we have to do. How would you do it?
We can use the dictionary here, right? That's a perfect use case.
Yes.
So for every word we add it to the dictionary as the key. And then if it is there, then we increment the value associated with the key.
Correct.
Yeah, split, iterate, and then just what Deepak said around the dictionary.
Correct. So let's do that.
Yep.
Okay. Right. We'll say count words. Do you think this this kind of logic is of any use? Count words, word counting is of any use in this modern time?
Yes.
Can you?
Yes,
in the
I mean, why not
recommendation.
Okay.
survey recommendations and whatnot? Why not?
Yes. So it has got lots and lots of use case. One is creating the characteristics of a text. In that we use an algorithm called TF-IDF, okay, which is essentially nothing but counting the words and dividing the frequency of the words with their general frequency. Okay, like for example, the is a very common word, so we want to eliminate the. So we divide the with the total frequency across documents. So you have 50,000 documents, okay? And what you do is first you compute their frequency of all words across all the documents, and then you pick each document and then divide the frequency of each word by the overall frequency. That's called TF-IDF. You will study that as part of NLP. So we do that to create a characteristics. Okay. Say for example, you want to, there has been lots and lots of use cases of this. For example, you want to do the natural language processing. So you would like to convert a text into list of words and their counts, and then you will feed that to the models because that's kind of characteristics. Okay, now let's go ahead. So this is my file name, okay? And I'm going to do the word count, okay? Now, who can help me? First open the file.
File family.
All right. And then
fh dot
line and file name. Oh, sorry, yeah.
okay.
fh dot read dot split.
Okay, let's say it that way. Okay. You are saying fh dot read dot split. Those are your words. Yeah, good. And then you're saying for word in words. Okay. Now we will create a dictionary, empty dictionary. Okay. We create a dictionary, empty dictionary. We'll say if word is found in a dictionary. Okay. What does it mean? It is essentially a quick way of checking if a key is there or not. Okay. Let's say name. Let's say word is the. Okay. And its frequency is 1 already. Okay. Now what we will do? We reach to cat. Okay. We'll say cat in D false, but is the in D? Yes. So you can see the is there in the D, but cat is not. Got it? And this is not about if, let's say, the value was cat for the, still this will be false. Okay. When we are saying something in dictionary, it's going to look up in keys only. Is everybody okay so far? So we are saying word in words, meaning if the word already exists in the dictionary, then, I'm sorry. So we are saying word in words, as in we read the entire text into the memory. We split the text. This split function splits the text based on white space characters. Okay. And that gave us words. Then we are saying for word in words, we are iterating over this list of words. If word already exists in the dictionary, what to do? You do the dictionary D word increase by 1. So this is your tally. This will contain the tally. Key will be the word and the value will be the number of times that word has occurred. So if the word is already existing in the dictionary, we are increasing it by 1. Otherwise, we are just setting it to 1. That's it. And then we are returning the dictionary. Let's take a look. Does it work? I'm going to use it with big.txt. So it has done the job. Okay. It shows that the has occurred 6,149 times and so on. The only problem is this the and this the are two different keys. Okay. The capitalize and the lowercase is that. Okay. So why not we just convert the word to lowercase? Okay. We'll just say word.lower and that's about it. Now, the has occurred 78,000 times and project has occurred 259 times and so on. Is everybody okay with this?
I have two questions, Sandeep. One is that after else you gave D word and if word in D, then D word plus equal to 1, which is we are adding 1 to that. But how
adding 1 to the count?
1 to the count. Yeah. So I'm unable to understand like how is in D parenthesis word, where am I storing the count? Because I'm just identifying what is the word.
So first time I'm setting the value to 1. So think of it this way. Okay. So this is my, let's say, initially this is empty, correct?
Mm-hmm.
D is empty initially. Okay.
Okay.
So, and let's say we encountered the, okay. So what we are doing, the in D, it says false. Okay, it said false. So what we did, we said D of the, okay, equals 1. Got it? So that basically added the as a key and 1 as the value. Okay. Next time what we did, next time when the comes, okay, we say D of the plus equal to 1. Okay, which means it is increased by 1.
Got it.
Got it?
Yeah.
So that's what is happening here. So we open the file, we read all the text from the file, then using the split, we split it. You can see if I copy this, okay, here the cat jumped over the rat. Okay, if I say split, what it does, it creates a list of words. Okay, so words is a list of words from this file. We are going over this list word by word, and then we are converting it to lowercase, checking if it exists in the dictionary. If it does, we are increasing its count by 1. Otherwise, if it does not exist, we are setting its count to 1. That's about it.
And then can we also sort the dictionary by the
Good question.
order?
Good question. So now question here is given a dictionary of counts, okay, find top, okay, sort the data first. Sort the words based on the count. You want it decreasing or increasing?
Either descending or ascending, yeah.
Okay, in descending order. Okay. Who can help me? Yes. So you have to write, right? Order words. Okay. Order, value, and key. Correct? Because value is, we want to order given a dictionary, we want to order the things based on the value. Okay? Based on the value. Order by value. That makes more sense, correct? And we'll say my dictionary. My dictionary. This is my dictionary and we want to order. Who can help me? Think of like normal, inefficient way. Don't try to optimize. Okay? Just very simple, like, yeah. Go ahead.
No. Count the total number of sort the different
Given a
entries.
dictionary of word counts, given the dictionary of word counts, okay? Word counts like key and values, sort the word based on the counts in descending order. Okay.
So Sandeep, here we will open the file first. Then
No, let's say we get this as a in-memory variable. Okay. Yeah. We are not right now saving it in the file. We just we can assume that you got the dictionary of keyword. Like whatever we'll get from this function, whatever this function returns, we'll pass that to this function, order by dictionary, order by value. Okay. Yeah, go ahead.
We can just take a look at the number. So the arrange, like get the number from like descending. So from small to the highest to the smallest.
Can we use the list sorting strategy?
We can, but how do I call the
Can we
numbers?
create a list out of the dictionary If we go over all the elements of a dictionary and put them in a list?
Yeah.
Okay.
Should be.
Let's say this is my list. Okay. This is my list. All right. Now what I'm going to do is I'm going to go over the dictionary. Let's say we will say for key in my dict. Okay. Right. I'm going to put them in the list. I'm going to say value equal to my dict and key. And I'm saying append the value first and the key later. Okay. And also, I can also do this. I can just put minus sign in front of the V, and that's about it. And I can say lst.sort and return lst. Okay. So let's take a look. First, we will do the count. Okay. Counts equal to this. And then order by value. Order by value. All right. So you can see the is the most popular word, then of, then and, then to, then in. So I basically use the sort method. Just that I did for descending, I just changed the line count to negative so that the largest number comes at the beginning because that becomes the smallest number by putting the minus sign. Okay, that's why I put a minus sign here.
Can we reverse? I mean, rather than minus sign. This is more efficient, but if you don't put minus sign, can we reverse it later? I mean, for example, if it is not a number, it is key, alphabet, number, right? Something
You can again
non-numeric
go over the
thing.
you can again go over the list and change it. You can just go over the list. You can iterate over this list. Right?
Can we reverse the list? We can, right?
Yes. There is a method. Oh, that's also a good idea. That's also a good idea. So you are saying, let's say we did this. Okay. And then after sorting, we could just say list.reverse.
Dot
Correct?
reverse. Yes.
Yeah. That's also a brilliant idea. This is what you meant, right?
Yes.
Yeah.
We can use the sorted function of dictionary itself.
Yes. A sorted function of the dictionary. Does it have a sorted function?
Has something like dict dot sorted.
No, I don't think it has sorted. I don't think the dictionary has a sorted method. Okay. What?
Like in Java, we have sort hash maps, right? In collection framework. So
Yeah, this is not this is I'll talk about that one very soon. Okay. This one it doesn't.
The split function, what is the separator for this function? I mean, like space, tab, and slash in only, or?
I think yeah, those are the ones. Space, tab, and the new line.
Yes. Because if I give full stop, that is like continue. I don't give any space between a word and full stop, then it is not recognizing. Word is not separated from full stop and all.
Yeah. Okay. All right. So does it make sense to you this way? And of course, if you want to just extract say top 10 words, you can do that. All right. All right. Those who are trying to, let's say, who are into pre-sales and are trying to get into Google or any of top companies, please know that Google in their pre-sales interviews, right, they have started asking these kind of questions. Okay. Just to let you know.
Pre-sales is different, right? I mean, pre-sales
Yeah.
is more of selling your products, right? Like what I mean,
Yes. Yeah.
giving
So
some
for their
workflows or
cloud, basically solution architect is what they call the title. They call the title as solution
okay.
architect.
Solutions
Okay.
architect. Okay.
Yes.
Okay. Then that
Role
makes
is
sense.
role
Yeah.
is to work with the sales guys, build the
Yep.
solution to the customers, and even in the role where you are customer facing and you're working with the
Yep.
customer, they expect you to know, like Google kind of company, they expect you to know the coding really well. Okay.
Yep.
So yes, and they asked to do this, and they asked the follow-up question to do the top 10 counts. Okay.
Okay.
And then they asked to do it in
Yep.
SQL. Yeah.
Okay. And Sandeep, just on the other side, like what do you think is the best cloud service provider? Google, Amazon, or Microsoft?
For what?
I mean, if you want to migrate your company workload to, let's say, cloud, what should be your strategy? I know a lot of companies are
Okay.
following
From
multi-cloud,
my class perspective, from a developer perspective, I'll tell you this. Okay. I think the debate can go on, right? But
Yeah.
most important part is when you're designing anything, design in a cloud agnostic way. Okay. Don't use, let's say, Amazon is providing you RDS. Okay.
Yep.
It's a database.
Yep.
Instead of using their RDS, use your own database.
Yep.
Okay. That is like, I'm just giving you example. Second, if let's say Amazon is providing you like a caching service or other things, don't
Yep.
fall. Build your own. Use them
Yep.
like a hardware provider. Okay. Not a software.
Okay.
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 Like
So
what Google themselves did, what Google themselves did in the beginning of their days.
Yeah.
Any cloud provider provides like free credits and all that. They will use their services for that many days, then move to another. Okay.
Move to another. Yep.
Yes. And they used to suck them dry.
Yep. Yep.
So Google made sure that all of their infrastructure is, portable quickly. Okay. While as of today, Google, Amazon, and everybody tries to make sure that your work is not portable. Okay, that's why they are more focused on software things. If you see
the service, right?
Yeah, because you will get stuck. Okay, so as an engineer, no matter what service you're going to use, make sure that your entire stuff is portable. You can just port between systems. Okay. And good thumb rule is use Docker. Docker is a way to just deploy things quickly. And use Kubernetes. Use all your services. Don't fall for any of them. Okay. And whoever is like negotiate with everybody, whoever is giving you more discounts and more credit, use that. Okay. And I think I did the same thing. For CloudxLab, first we used GCP, then we went to Amazon, then we came back to GCP because they gave us credits, and yeah. But now we are stuck with
So
both
you
of
keep
them.
moving in then. Okay.
Yeah.
That makes sense.
Okay. Yeah.
Yeah.
Because see.
Okay. No, I mean it's I mean the market is pretty. I mean what I noticed here, at least in Australia, the market is pretty odd actually. If you go for a cloud architect or cloud consulting position, they look for a specific cloud person actually. So some ask for Azure architect,
Don't go for
some are
that.
asking for AWS
Don't go
architect.
You don't hire such people. Okay. So if somebody says, I am a GCP person, I'm not a AWS person, don't hire a person. Okay.
Okay.
Always hire engineer. Don't hire
Don't
a specialist. Okay, it becomes a pain, right? It becomes a very difficult exercise to, fire people once you move from AWS to GCP and your AWS people say, we don't touch GCP. It becomes very awkward. And on top of it, you will
Sandeep,
develop, yeah.
in clouds, which cloud has like greater scope, like AWS or Azure or GCP?
Answer is same. Go for
multi-cloud.
like the way we have designed our DevOps course, right? What we did was we basically did the common tools, like open source tools that everybody uses, like Docker, Kubernetes, and Puppet, the Grafana. All of these tools are common open source ones. Okay, so upskill yourself. Don't upskill yourself with this stupid people like the Google kind of guys. What they do is they make sure that you only know the things that they are providing. Okay, so it's kind of makes you unemployable very quickly.
Yeah,
Okay.
also it makes little shallow of like
Yes.
creating scopes.
Yes. So it might give you instant job, but in a longer run, you are jobless. Okay.
Yep.
So again, my answer always remains same. As an engineer, you should think of them. You should
As a
think,
platform provider,
yeah, as a tool. You are not religious, right? You are not religious saying that, okay, I will only do these things. No, you are not religious. You are just using all of them as a tool. Okay. And all of them actually just use the same Linux. That's why in my classes, I emphasize a lot on Linux learning, a lot on Python learning, and a lot on the general learning. The more generalized your knowledge is, the better you will do. Okay. Yeah. And whatever we are learning, yeah.
I was saying the other disadvantage of that is that you begin to create systems which are vendor dependent.
Yeah. Yeah.
Yeah.
So I remember
By the way,
like
there is a sorted function available. It has to be something like tick.sorted.
yeah. So so I remember there was this one of my person who used to live in the same apartment where I used to live. So he came to me earlier that, hey, Sandeep, I need to build this software. I said, hire a full-time engineer and build it. But he went for some agency to do the work for him. So he got it developed. Now, when he put it to production, everything was so slow, very, very slow. And the person who developed it, he said, I can't fix it. Okay. Because he must have messed up somewhere with the data structures, right? Somewhere the order of complexity is O(n) square and it has made it slow. Now, this person is like, afterwards, I came to know that he went to another developer. The developer said, oh, this is slow because you are using Python. We will use Java and it'll become fast. Okay. So he ended up, he ended up spending a couple of more months. And then after developing in Java, now it doesn't have those few features, right? So the main problem is not in frameworks. The main features are not in the platforms. The main features are in the engineers because they can figure it out. Okay. Right. The people who wrote Mario game, you remember that the game? It runs in few megabytes. Okay, I think 2 MB it runs entire thing. So an engineer can make it happen with almost zero hardware and almost no, I mean, very small hardware and very, very old programming languages. Okay. And it's not the magic is neither in platforms, magic is not in programming languages. Magic is not in a particular framework. Magic is in the way you code, right? Those who do not know, if you see a book called Art of Programming by Nuth, okay.
Right?
Yes. So that guy has written a new programming language for that book. Okay. It's called Mix. Okay. And this is like an assembly language. Okay. Every algorithm that you see, every algorithm that you know, right, is written in Mix. Okay. Recursion and whatnot. Everything is written in that Mix language. Okay. So it's a very important thing, because almost every algorithm that you know, right? Even let's say when you do Control F and you are looking for a word in this, right? This algorithm is called, you know the name of this algorithm? Though it might sound very simple, like, okay, what is so big deal? Go over the page and such. But what he did, so there is an algorithm called KMP. KMP is Knuth Morris Pratt. Now, in this algorithm, what he did was he figured it out a little more optima, so that when you are searching, if you've already searched, it has a strategy to jump ahead. Okay. So the most complex algorithm probably in my life is that called KMP. Okay. So KMP, if you look at KMP, okay, Knuth Morris Pratt algorithm. Okay. It's for searching of a big word in the text. Okay. Now this is basically written by Knuth himself. So what I'm saying is that when every algorithm can be coded using an assembly-like language, therefore everything can be achieved using any programming language, any framework. Okay. So keeping that in mind, my very, very, very strong suggestion to everybody is to get comfortable with the things that we are discussing in this class. Okay. You will thank me later. Okay. Okay. You will thank me later about this. All right. So irrespective of platform, irrespective of cloud provider, irrespective of database, irrespective of programming language, you should be comfortable with converting your thought into code, and also comfortable in optimizing it. Okay. And in that, the dictionary comes as a very, very handy data structure. Say, for example, we did the word count, right? Those who do not know how to code word count, they'll say, okay, we will use somebody's algorithm. We will load this data into a database, and then we will use SQL to do the word count by using the grouping. There's nothing wrong in it. But again, you get to know that part. All right. So, okay. I'll just change this to, yeah. Now, we were able to do the order by value, and we were able to do the word count, correct? Now, able to find the counts of the word. Is there any doubt on this particular part? Yes, no? Everyone? The order by value? Are you able to feel the things that we are doing, or is it looking very weird? No.
Sandeep, one quick question. So first you sorry. First you did sort with -v, and then we did change it to reverse, right? Does it does dot reverse create or adds some time complexity, or dot reverse is fully optimized because it's inbuilt the way it is?
Hello.
Okay.
Yeah.
Got it.
Got it. Got it. I was not speaking.
Mm.
Okay. Sorry, Deepak. Okay. All right. So the order of like when you do sorting, the sort method usually has an order of n log n, while this one has an order of n. So n log n plus order of n is essentially n log n. You basically, this is lesser in this. So it can be ignored.
Yeah. Okay.
All right. Is this okay, everyone?
Yep.
Perfect. Perfect. Now, my question is, how would you find the word count? So this is great. This is great. Okay. So far, everything is good. Okay. So, and you guys are comfortable with the dictionaries, right? Yeah. One more thing I want you to tell. If you want to delete something from the dictionary, what do? Let's say this is my dictionary. Okay. I want to delete the key. Okay. So you can say del and you can say the. Okay. If you want to drop a particular key, you can say delete. All right. So you can access a particular key, you can set its value, and so on. The other thing we could do here, I just want to show you one more method, and then we will move on to solve some more hard problems. Okay. And I want to spend a couple of next weeks in discussing algorithms, specifically sorting algorithms in much more details. Okay. All right. Or let me just finish these topics. What do you say? One way could be that I want to just touch upon the object-oriented programming, and then I want to do the data structures. These things I can do after data structures. Okay. Because the network programming and modules and packages, or maybe I can just finish the modules and packages and these, and then yeah, I think I can take up the data structures and algorithms probably just by after going over the syntax. Okay, that's what I was thinking.
After
And
going
what?
sorry, after finishing the basics, right? That's what you
Yeah,
said,
that's what
or?
I'm thinking. Yeah, that's what I'm thinking.
Okay, that makes sense. Yeah, at least you have the
Again and
basics.
again, because what's happening is I keep thinking that okay, you may get freaked out when I talk about the classes and objects. Okay, so I'll
Yep.
just cover the classes and objects and also finish the modules so that you are comfortable with the packages and stuff. All right. So I'll just quickly cover that. That'll be pretty simple to you. And the cool part about Python is actually things are so simple. Things are so simple as compared to any other programming language. It has probably the simplest way. It's so difficult to make things so simple. And yeah. Now, where was I? I was talking about, here, if you see here, right? Is there a better way? I'll just comment it out so that I can just hide it. Cell type, current outputs, toggle. Yeah. So I toggle the output now coming here. Can you make it better? Here, we first went through the keys. Okay. There could have been another way we could say keys. Okay. That's same as this one. Okay. Now, and then we are accessing value. The other cool way is saying items. Okay. And you can say for key comma value in items, and that's it. Okay, so you can basically just replace that logic with this. Is this okay? So items means when you say dictionary.items, when you have, let's say, where did we define the dictionary? We did define the dictionary somewhere, right? Yeah, let's say this one. Okay, if you say d.items, what it does, it basically gives you a pair. It gives you a list of pairs. Okay, and you can iterate over this list while assigning the key and value to the key and value. So we are basically saying key and value in items. Okay, this is same as saying for item in items and key and value equals to item. Okay, these two syntaxes are identical. Instead of
Sandeep,
having two steps.
sorry to cut you out. How does this list dot sort become order of n log n?
I'll talk about that.
I feel like it's only n. I mean, I could be wrong.
So, really?
Yeah, that's what I feel like.
How would you sort the numbers? How would you sort the data?
I mean, take 2 pointers n plus 1 and then keep
Okay.
comparing it.
Okay, let's just start with that. Let's say you have 1, 10, 2, 3, and 4, let's say -4. Okay, tell me, how would you?
So let's say define.
Yeah,
Sort
before jumping there, I want to just seek a confirmation. Is this clear? Like key comma value in items. Okay,
Yep.
I hope that's clear to everyone. Right, now the question is how to order the data, how to sort the data. Anybody wants to try? You are saying, can you tell me your strategy?
I mean, just take 2 orders. I mean, take 2 probably x.
Okay, let's say we took
x0, x1 and keep comparing, right? Like, yeah.
Okay, so you compare 1 and 10. You compare 1 and 10, right? So,
yeah.
and
So
after comparing, what do you want to do?
then move. I mean, if not successful, then move the arrow 1 place afterwards. 10 and 2. So
Okay.
if 10 and 2 is the smallest, right? So move it back, and then 10 there, and then you.
Okay. Okay.
Yeah, and then yes, follow the similar order. I mean, if the number
Okay.
is,
Let's do the
previous
counting.
number is.
Let's do the counting in your case. How many? So 1 will be compared with 10.
Yep.
Will be compared with 2. Will be compared with 3. Will be compared with -4. Right?
Yep.
And then 10 will be compared with all of them. Then 2 will be compared with it, right? Which is how much? What's the order?
5, 4, 3, 2.
N square, right?
Yes. Yep.
Error.
Okay. Got it. No, sorry. Yeah.
Okay. So yeah, I think
and login.
Yeah. So it's very tempting right now to jump into sorting, but I will hold myself back. Okay. So I want everyone to look at various sorting methods, starting from bubble sort. Okay. Merge sort. Quick sort. Okay. Check out the animations. Okay. I want everybody to just check out the animations. Okay. Animation of bubble sort. Okay. So yeah, this is an amazing blog. This guy has done a marvelous job. Okay. So this is your random list. Okay. So you take two lists, sort them, take another one, sort them. To keep on doing that, keep on doing that, keep on doing that. All right. So experiment with all of the algorithms. Okay. So it's very good work this guy has done. Where is that? Animations. Where is? Oh, how do you this? Oh man. Anyway, I think Google is a better one. Okay, so take a look at the bubble sort. Take a look at, say, other algorithms like merge sort. Okay, the algorithms like merge sort are more frequently used, right, as compared to any other. They are probably merge sort is the most efficient algorithm and is the one that is used very, very, very smartly. Those who are curious, those who are curious, but I would say everyone should try. Okay, so it's a very, very, very smart algorithm. Okay, and the simple answer is it is basically a divide and conquer strategy. Let's say you have these values. Okay, so what it does is it divides this array into two parts. Okay, two parts. So it basically sliced the elements. You can see first half went to the left and second half went here. Then again, it divides them. Again, it divides them. Okay, until only one element is left. And when the element is that way, then it basically merges the list. So it basically does 410 and 868, ordered them. So it became this order. Okay. Now, okay, so it sorted this list. Now it'll sort this right-hand side list. Okay, in the same way. Okay. Now it sorted these two lists. Now what it does is it merges them. So these two lists are sorted, correct? These two lists are sorted. And how do you merge the sorted list? Hold on to their heads. Hold on to their heads. Whoever, right? Who like it selected the first number from both, picked the smallest, put it in the outcome. Then it compared this next one with the first one, picked the smallest, put it in the outcome. Now it picked the next one, and so this way it merged the two lists. Okay, and essentially that's what it keeps doing. And once it is done with merging, sorting the both parts. Okay. Now it basically just a divide and conquer, right? Basically, the core algorithm is merging the two sorted lists. Okay, now look at this. So what it'll do is it would to merge these two lists. So pay attention. Okay, so we got this list and this list. Both of them are individually sorted. You can see. So it'll do is it'll pick the small one, put it in the output. then move to the next one. So compare 297 and 257, put 257 in the outcome, move to the next one. Compare 847 and 297, put in 297 in the output, then move this here, then compare 410 and 843, so it 410, and then compare 496 and this, 496, sorry, 596, and then it moves here. So like that. So it's pretty smart algorithm. Just like in the prayer assembly, if you have to merge, like there were two queues of the kids, one, and both the queues were already sorted and you had to merge. So you will stand in front of both the queues and then merge them. Okay. So this is the best algorithm on sorting. So do take a look at the animations, and this would really help you. Okay. So check out the animations of quick sort, merge sort, bubble sort, and try to calculate their complexity. Okay. And try to code them and calculate their complexity. Okay. So yes, I would say that do this homework. Trust me, it's going to help you. Okay. All right. So that is a assignment that you should do. Okay. All right. Check this out. Honest suggestion to everybody. Okay. All right. So bubble sort, inserts and sort is also one thing that you can take a look at. All right. We will get back to this very soon. Okay. So there are lots of things to be done on everyone side. And one of the things that you should spend your time over this week is looking at the animation of this, trying to code them and try to calculate their complexity. Okay. Do that. Trust me, sorting after the binary search, sorting is the next most important thing, because for binary search to work, you need to sort the data. Every database, when you are creating an index or doing anything, it has sorting involved in it. Every big data tool, like when you think of Hadoop, Spark, big names, right? They're all basically sorting engines. They help you sort very big data. Okay. So sorting is the heart of everything. Okay. So I would want you guys to work on it. Okay. Not because we need the lot of sorting code, but because everybody need to understand sorting. Okay. Because if you don't understand sorting, you won't be able to answer many questions in the interview. Okay. So please pay attention, put your entire heart into it. Okay. And it doesn't require any prior knowledge. The computer science doesn't require any prior knowledge. Okay. So please go through this, and we will talk about this probably next week. Not next week. Next week, I'm again going to finish the topic, and then we will come back to this. But in the meantime, try to answer these questions, the one that we discussed today, and spend good time on sorting. Trust me, it will be very helpful to you, because it's not like biology, or it's not like economics, right, where you need some other knowledge. It's a simple logic game. Okay, it doesn't require any other knowledge than simple things, right? So I'm just committing the code.
Sandeep, I just had a quick question in regarding the sorting algorithms which you mentioned. So all the, like, let's say the 4 different sorting algorithms has its own specific unique use cases, or is it like you can just like choose and use or whichever works for the
Yeah.
sorting methods
Yeah.
itself?
So, okay, first, I want you to figure that out. Okay. Second, just to give you a perspective, these two algorithms hardly anybody uses. Okay. People use either merge sort or quick sort, and merge sort is the most generic and most stable system. Okay. Between quick sort and merge sort. Okay. So, in simple words, probably I think the when you say list dot sort, when you say x dot sort, okay, it probably uses the merge sort. Okay, you can take a look at. Okay, so in very simple words, the sorting algorithms are already sorted, right? Everybody has figured them out. Though every year or every once in 2 years, people come up with new sorting algorithms. Okay. And I mean, in very simple words, most likely you will be using merge sort or quick sort. But the most important part is knowing how they work. And you will be amazed. You will have this wow or aha moment. Like, did you get the aha moment when you saw this animation here? No?
I got the aha moment in binary search in itself. So
Yes. So you'll get the similar aha moment. And you'll get the similar aha moment when you think about where is the sorting happening? You know, one of the questions that interviewers ask is that in merge sort, right? Where did the sorting happen? Right? Basically, it's only merging. Okay. Two elements, one element and one element got merged, and that created a list of two elements which are sorted. Then two elements and two elements both are sorted. When they are merged, that creates a sorted list of 4 elements, and then 8 elements, and that's how. Okay. So this is a very, very simple algorithm and just very powerful. Okay. And the important part is to count where is to count the complexity of it. Okay. The most important part is to count how it is n log n. Why it's not n square. That's the most important part. Okay. So pay attention, play around with it, try to calculate how many steps are required to sort n number of elements. Okay. And you'll be amazed that it's actually n log n. Okay. And log n and n square are very big difference, right? You can see if you have a million elements, okay, right? If n is equal to 1 million, right? How much is n square? N square, 1 billion. And how much is n log n? Yeah. 6 million. Sounds crazy, right? Only 6 million. Right? Here it's billion. Okay. So billion seconds versus 6 million seconds. Or if it has like, no, it's not billion, it's trillion. Sorry. Million, billion, and trillion. Correct? And square is trillion, right? Yeah, it has 10 to the
Yes,
power.
it is more than a billion for sure.
Yeah. So it has to n square algorithm has 10 to the power 12 steps. And this has 6 into 10 to the power 6 steps. Now this makes all the differences. The algorithm like bubble sort or insert sort and the Rahul sort, the one that we did today, right? That one would take 10 to the power 12 steps, and this one will take 6 million steps, right? So that's the difference between n log n and n square. Okay. All right. So yeah, this is the real magic of computer science. This is the real wow or aha moment for in computer science. Okay. All right. So spend time on it, and there is nothing beyond these basic things in computer science. Nothing beyond. The hardest things are easiest things combined together. Okay. So yeah. All right. Thank you, everyone. I hope everybody was on the same page.
Thanks, Sandeep.
Thank you, everyone. Have a good day.
Bye-bye.
Thank
Thank
you.
you, sir.
Thank you, sir.
But yeah. This week, everyone, please spend your time on sorting algebra. Okay.
Sure, well.
And yeah, I have anyway committed the code. Yeah. Thank you.
Thank you, Sandeep, sir.